Hey guys, Mr. McKinney here, just going through how to find the derivative of inverse functions. So for today's video, we're going to be thinking about functions that are inverses of each other. So let's talk about inverses for a little bit, and then we'll talk about how it applies for calculus. First of all, when we talk about an inverse function, this is the notation that we're going to use. So f, it looks like the power of -1. You don't say f to the power of -1, though. You say f inverse of x. So this is the inverse of the function f. Now, in a previous math class, you would have talked about inverses, and you would have talked about how they are a reflection over the line y equals x. So if my original function f of x looks like this, then the inverse would be reflected over the line y equals x. Now, let's think about a couple of different things that we can just figure out by looking at the graph here. First of all, there are going to be these things called image points. So an image point is just a point that corresponds to a point on the inverse. So the point AB on f of x corresponds to the point BA on f inverse of x. In a previous math class, you would have talked about inverses, and you probably talked about switching x and y and then solving for y. So when you have the inverse of a function, it's whatever undoes the original function. So if I put a into f of x, I get b out. And if I put b into the inverse of f, then I get a out. So the inverse is what undoes the original function. Now, for today's lesson, if we're going to have an original function as f of x, the inverse we're going to call g of x. So let's think about the relationship between f of x and g of x, and think about the slopes at these 2 points. So if I look at the slope at this point on f of x, and then I look at the slope of this point on g of x, they're both positive slopes, and they're not parallel because we can see that they would cross each other. So they're not parallel because they're crossing, and they're not perpendicular because if they were perpendicular, one would have to have positive slope and the other would have to have negative slope. So these are neither parallel or perpendicular, but there is a relationship between these two slopes. And basically, they end up being the reciprocal of each other. So for example, if this was a slope of 1/3, that would mean that this is a slope of 3. So they're reciprocals of each other. So let's think about what we would call the slope at this point. So at this point, we would call the slope comes from the derivative, so we would call that f prime of a. Over here, I would have the slope of g at this point would be g prime of b, because b is my x value here. So the slope for g at b, we said it was going to be the reciprocal of the slope at this point. So it's going to be the reciprocal, so 1 over, and then the derivative of f, not at the same value though. It's at the value that corresponds here. So it's f prime of g of x, or g of b. Because g of b is really just a. So this is really saying that like g prime of b is 1 over f prime of a. Because if I found the slope here, I want to do the reciprocal of that. Now the way to get a is it's what would come out of g if I put in b. Hopefully this will make more sense as we go through the video, but this is just a little bit of thinking about where the formula comes from. If this didn't make sense, don't worry too much. Just copy down the formula on the next page and then apply it as the examples will show. All right, so this is the formula that you need to get into your notes. So make sure you copy this one down. If g and f are inverses of each other, so that's a really important step. You can't just do this with any random functions. But if you know that two functions are inverses of each other, then you can find the slope or the derivative of one of the functions using the other function. And you use this relationship. So g prime of x, the slope at g at any x value, is 1 over f prime of g of x. And you can go back and look at my mediocre explanation, maybe rewatch the last couple of minutes if you want to see where that comes from on the picture. If you don't care, just memorize this formula and then watch how we apply it. All right, so f and g are inverses. I want to find g prime of 15 if f of x is equal to x to the 5th power plus 2x. So I'm going to start with my formula. G prime of x is equal to 1 over f prime of g of x. So this is the formula that I'm going to be working with. On this problem, it wants to know what g prime of 15 is. So g prime of 15 is going to be 1 over f prime of g of 15. All right, so there's a couple of things that I'm going to need here. I'm going to need a rule for f prime. I can get that from the equation. And then I'm going to need a value for g of 15. I don't have the g function, so we'll talk about how to find that. Let's find f prime first. So to find the derivative here, we're just going to use the power rule. So f prime of x would be 5x to the 4th plus 2. So this is the rule that I'm going to use here, but I need to figure out what g of 15 is so that I can plug that into this rule. Now, I want to know what g of 15 is. I don't even know what the function for g is, so I can't do it based on the g function. But I know that f and g are inverses of each other, and that means there's image points. So if the x value for g is 15, that means there's some point on f where the y value would be 15. And whatever x value gave you 15 as the output for f is going to be the y value that you would get for g if you put 15 in. So whatever this number is going to be the same as this number. So I'm going to set the equation for f equal to 15 and solve it. Once I solve it, I'll be able to figure out what x is. And then we'll plug that in over here. Okay, so I'm going to start by setting x to the 5th plus 2x equal to 15. So this is going to tell me what x value f gives an output of 15. Now, we don't know how to solve 5th power equations by hand, or at least not very easily. So let's just use a calculator to solve this one. You can graph this one in y1, graph this one in y2, and figure out where they cross. Or graph x to the 5th plus 2x minus 15 in y1, and then graph 0 in y2 and figure out where they cross, or find zeros, or use Desmos. There's a variety of different methods to solve this equation. But when you solve it, you should get x is equal to 1.636219 and some other decimals. So that x value is what gives 15 as the output for f. So there's a point 1.636, comma 15 on f, which means there's a point on g that is 15, comma 1.636, which means that g of 15 is 1.636. So now I have the information I need. I can just plug it into my formula. So going back over here, g prime of 15 is going to be 1 over f prime of g of 15, we found out, 1.636. Now, you're doing this on a calculator, so just keep all the decimals there. I don't want to just keep writing them out. So keep the exact value in your calculator. Now, again, this is f prime of that number, so don't plug it into f, plug it into f prime. So g prime of 15 would be 1 over 5 times 1.636 to the power of 4 plus 2. And then if I plug that into my calculator, I'm going to get an answer of 0.02643. So g prime of 15 is I don't know what's going on here. G prime of 15 is going to equal 0.02643. All right, I'm going to talk through that again. We had our formula. Our formula needed f prime and it needed g of 15. F prime is easy to find. To find g of 15, I'm going to find the point on f that corresponds, or the image point. So there's a point on f that has a y value of 15, And if you switch the x and y coordinates, that's going to give you the point on G that we're looking for. So I set the equation for f equal to 15, and I solved it. So this is the value that gives me 15 in my f function, which means that's what G of 15 is. Then I'm just plugging it in and letting my calculator do the math. So this is a calculator example. This is a non-calculator example. So same idea. I want to find G prime of 7. I'm given the function for f, and I want to figure out, like knowing that f and g are inverses, I want to find G prime of 7. So I'm going to start out with my formula again. G prime of x is 1 over f prime of g of x, as long as f and g are inverses. So I'm going to need an equation for f prime, and I'm going to need to know what g of 7 is, because I'm going to do 1 over f prime of g of 7. So f prime of x would be 3x squared plus 4. I'll use that later on. So now I need to figure out what g of 7 is. And so again, I don't have the function for g. So I can't just plug 7 into a formula. But I know there has to be a point on f that is the image point for this one. So there's some x value here that's going to be the same as the y value here. So I need to know when f is equal to 7. Not f prime, but when f. So x cubed plus 4x plus 7 is equal to 7. Let's practice solving this without a calculator. So anytime you have a higher order function, you'd want to make it equal to 0. So x cubed plus 4x, subtract the 7, is equal to 0. Factor out an x. So now either this equals 0 or this equals 0. So x equals 0 or x squared plus 4 equals 0. X squared plus 4 would give me x equals positive or negative 2i. We don't need to worry about the imaginary solutions. So we're going to use this point. So the point 0, 7 matches up with the point 7, 0, which means that g of 7 is 0. So that's the number that I'm going to be plugging into f prime. So g prime of 7 is 1 over f prime of 0, because that's what g of 7 is. So g prime of 7 is 1 over, and then my equation for f prime is 3x squared, so 3 times 0 squared, plus 4, which would be 1/4. Now, in theory, there's another way to do this problem. So you could find the inverse of this function and then take the derivative of that. But this is so much easier, so don't try to do it that other way. All right, that's basically it for today. This is the main formula you need to know how to apply. Just rewatch these problems if you need help. There's 2 whiteboard problems here, so go ahead and hit pause. The first one you should be able to do without a calculator. The second one, you should be using a calculator to figure out the solution that you're going to need. So non-calc on the first one, calc on the second one. Let's see how you guys do. All right, let's see how you guys did. So on the first one, it's really not too bad because they already gave you this point on f, which turns out to be the point that we need for g. So we already knew that g of 1 was pi over 4. We didn't have to do any extra work on this one. So when I plug it in, the derivative of tangent is secant squared. So I'm doing 1 over secant squared of g of 1, and g of 1 is pi over 4. 1 over secant squared is just cosine squared. Cosine of pi over 4 is root 2 over 2. If I square that, I get 2 over 4, which is a half. On the bottom one, we'd be using a calculator. So set this equation equal to 15 to find the point that we're interested in. So that's going to give me the j of 15 value that I need in this formula. Derivative's pretty straightforward, and then I'm just going to plug it in and let a calculator do all the work for me. Again, this is a fairly short lesson. Technically, there are other ways to find the derivatives of inverse functions, but if you try to do them the other way, you're going to run out of time on the AP exam. So for example, we could say that g of x is tangent inverse for this function. That's the inverse of tangent, is tangent inverse. And in the next unit, we're going to learn some terrible formula for tangent inverse. And you can use that and it'll spit out the same answer. But this way is way easier. So if you know that functions are inverses, then memorize this formula and just use it. All right, hope this was helpful. Good luck.